Welcome to JBros channel. In today's session, we are going to learn about generative. This is a subset of AI, machine learning, deep learning, and then all generative model with the NLP content. So, generative AI creates a new content that is like images, any images, video it can generate based on the patterns in the existing data. So, we are going to learn with LLM and SLM, that is large language models and also small language models, and then retrieval augmented generation, which is called as a RAG. That also we are going to learn in today's session. So first we will start with our Gen AI. So generative AI is a type of artificial intelligence that can create a new content such as text, images, videos and more based on the patterns and structures it has learned from the training data. So as I said, it has a LLM. So large number of data is necessary to generate a new content. Same way, there is a opposite for that. Small language model is also there that's focused for specific task with less data. So SLM is also there, LLM is also there, which uses the deep learning technique only to generate a new content. So generative AI model operates based on the natural language processing and use the natural language inputs to produce the complex results. So it need to identify with the data science preparations, and then it need to go with the transformer architecture for generative AI, and that uses the machine learning algorithms. So with these techniques only we can able to generate a model for understanding what kind of pattern and structures are available in the massive data sets to create a new content of the text or image outputs. So these are the types of Gen AI. Already we have studied about RNN, that is recurrent neural network in machine learning algorithm, and then convolutional neural network, which comes under the machine learning model, that is neural network, and then GAN, which is a generative adversarial networks, and then transformer models and by variational encoders and autoregressive model. Autoregressive model already we have studied in our data science concepts. So same thing only we are going to learn here also with comprises the autoregressive model. Now we will move with remaining things. We will study one by one. First one is a transformer model. That is mainly related for our NLP along with Gen AI. So a transformer model produces the encoder and decoder pattern of the data, that is underlying pattern. So that was introduced in the Google by Google in 2017 in the landmark paper Attention of All You Need. From that only that content of encoding and decoding technique adopted in the text processing mechanism, that is called as the attention here. So that changes the how the language model can be trained. An encoder converts the raw and annotated text into representation known as embeddings. The decoder takes these embeddings together with the previous output of the model and successively predicts each word in a sentence. So transformers are processed words in a sentence all at once, allowing the text to be processed in parallel. So for making the or speeding up the training model. Earlier, we have learnt about the RNN, and then not only the recurrent neural network along with the short-term memory, LSTM, that is a long short-term memory, which is used by the neural network. So with that concept only, the transformer is also we need to learn. So transformer also learn the positions of words and their relationship in the context that allowed them to infer meaning without any unambiguous words. Whatever the long sentence is there, without ambiguity. It need to produce the sentence. By eliminating the need to define the task, the transformers made it practical to pre-train the language model on vast amounts of raw data or raw text, allowing them to grow dramatically in size. So for that purpose only, the encoding and decoding technique is used for by the transformer. And also the transformers have come to be known as a foundation model for generative AI and also for LLM, that is a large language model. Language transformers are non-generative tasks like a classification and entity extraction, similar kind only we will use the transformer model. And also generating the task like translation, summarization, question answering. For that purpose we can use this transformers. And large language model that uses the transformers are divided into three categories. First one is a encoder only model, and then decoder only model, and put together hybrid model of encoder and decoder model. Already we have studied about BERT, right? Encoder model that uses only the BERT, that power of search engines, and also Watson assistant. These are the some of the examples which is used for the encoder models, encoder only models. And then decoder, already we know what is ChatGPT. In that GPT and then Google Palm, Open Access Bloom, that will come under the decoder model. Then encoder and decoder together takes the concept of encoder and decoder model, which comprises the ChatGPT and then text to text transfer transformer, and then that is called as a T5. That is entire thing we can transfer that into text to text conversion. And then BERT and ChatGPT, right now whatever we are using, that can be comes under the transformer model only. Then we will learn about the so GAN is the uh, generative adversarial network. Before that we will learn about the encoder, autoencoder and decoder. So autoencoder work because we know encoder and decoder is important for transformer. That only we are going to apply for our NLP or generative AI. That autoencoder work by encoding unlabeled data into a compressed representation and then decoding it back into the original form. Plain autoencoder were used for various purposes and including reconstructing corrupted or blurry images. Variational encoder, autoencoder added the critical ability to reconstruct the data and output variations on the original data. The ability to generate a novel, new data ignited a rapid fire succession of new technology is the GAN model. That is a diffusion model capable of producing more realistic, but it is not a original, but it can produce the fake image. So for that purpose we will use the GAN. Some of the encoder and decoder architecture to be adopted for our Gen AI. Now, whenever we are talking about Gen AI, we need to learn about prompt engineering also. So first we need to know what is prompt engineering. So prompt engineering, generative AI system that is designed to generate a specific output based on the quality of provided prompts. Prompt engineering helps generative AI model better comprehend and respond to a wide range of queries. The basic rule for the good prompts equal to good results. So whenever we are giving the good query, then only our correct output will be resulted. So generative AI refers to the iterative refinement of different prompt engineering techniques to effectively learn from the diverse input data and adapt to minimize the biases without any confusion and produce the more accurate response. So for that purpose, we will use the prompt engineering. And the prompt engineers can play the important role for producing the AI models with Gen AI. So their intention is they have to get the proper query as well as they have to properly provide the answers. So prompt engineering is a large technology organization. Whoever hires the prompt engineers, they have to develop a new creative content with the NLP task. So machine translation to be improved and also NLP task to be identified with the complex question and answer through the prompt engineering. So for the prompt engineer, there should be a deep understanding of the large language model, strong communication skills, and ability to explain the technical concepts. And they need to be a program expertise. Then only they can able to understand the concepts in the existing data set. They have to identify the AI with a deep learning and learning technique with the vocabulary, nuance, and then phrasing, context, and linguistic models. Because every prompt can influence the outcome of the uh, new content. So for that, they should take care of all those things, and also they need to effectively convey the necessary context. That is also important for prompt engineering. And not only the context, instruction, content, and then data to the AI model, everything they should properly convey to the AI model. Then the entire goal of the prompt engineers are they have to run the model in a proper way, effectively conveying, and they should understand the concept of, if they are going to generate an image or video, the concept or working model of the environment they should understand. That is art history, photography, film terms. So everything they should know how to narrate and get the exact content of the prompt engineering. So based on that, the prompt engineering is divided into three basic concepts. One is a zero shot prompting that provides the machine learning model with a task it has not explicitly been trained on. So that way the zero shot prompting is trained, and it tests the model ability to produce the relevant output without relying on the prior examples. So that is called as a zero shot prompting. Then few shot prompting or in context learning that gives the model a few sample outputs or shots to help to learn what is request what it want to do. So this learning model can better understand the desired output if it has a context to draw it. And another kind of prompt engineering is the another principle is chain of thought prompting, that is COT. That is advanced technique that provides a step-by-step reasoning. So each and every time why it is happened, why how it is happened, yeah, without any explanation they cannot move further. So that kind of model is used for the chain of thought prompting each and every step for the model to flow. So in this that provides the more accurate results and creating the better understanding the language which is defined in the particular data set or particular context of the original data. So the in this generative AI, this RAG is the important concepts because this is the future of Gen AI. Retrieval augmented generation makes the LLM model to represent how the embeddings transformer and information is extracted and transformed to some other better way for understanding or LLM generative process, how it can be done. Everything is analyzed with the RAG only, that is retrieval augmented generation. In case if we have small number of data set, then we need to apply the augmented generation within that small number of data set. We cannot provide a proper or accurate results. In that case, we need to elaborate the augmented generated data set for producing more accurate results. So for that purpose, this RAG is used for uses the vector database. So in case in LLM, sometimes even if the data set is having a particular massive data, it it may lead to some misleading output, so it may be inconsistent. So exact answer if we are not able to produce, then whatever the model we are going to train, the entire thing will be wasted. So what we need to do is we need to use the retrieval augmented generation from the raw data source, and then we need to the pre-processing steps, all those things we need to do: information extraction, chunking, and then embedding everything to be put it in the vector database. If you are going to learn with the vector database, there are different kinds of data model we will use, and also we can provide the object ID for the vector database, which is used for in the any kind of unstructured data. So by this we can query the embeddings, and also relevant data can be provided through the from the vector database that produces the processed with the LLM model, and then a response is properly we can generate with the more accurate result. And also whenever there is an updation in our database, that is also we can provide that as a output for RAG. So this way our retrieval augmented generation is the next feature of Gen AI. So this way we have learned about the basic idea about the